Grade 12, let us look at question 9. Physical Sciences paper 1 from November 2022. Let's get straight to it without any waste of time. Question 9, which is AC and DC motors and generators. It is electrodynamics. Let us look at electrodynamics, question 9. We are given a diagram here. The diagram below shows the initial position of the coil in a simple DC generator. Once you see DC generator, you must know that we must use the right hand rule. We must use the right hand rule here because we are given a DC generator. The coil is rotated in an anti-clockwise direction. So as you can see here, this is anti-clockwise direction as shown below. Now let us look at our questions here. You must name the component. This is 9.1.1. We are asked here to name the component in this generator that ensures that the induced current in the external circuit is in one direction only. And then this can only be a split ring. So your answer here will be a split ring. We have split rings and slip rings. So don't confuse the two. We have split ring here. They also call it a commutator. So it's a commutator. It's a commutator. All right. So if you say split ring, in fact, if you say split ring and commutator, you still get the same mark in the exam. Okay. Split ring and a commutator, in fact, commutator. All right. And then let us move to 9.1.2. They want to know the direction here. The direction is the direction of the induced current from X to Y or from Y to X. So this is where you use your right hand rule. You know, this is where you use your right hand rule. Your right hand rule. So now with this right hand rule here, what you need to know is that you have your thumb, which represents the force. You have your index that represents the direction of the electric field lines. And then you have your middle finger that represents your current. So if you go to this diagram here that we had, here, and you use the right hand rule, it means that your index, since your index represents the electric field lines, it will move from north to south. And then since it is rotating anti-clockwise, for it to rotate anti-clockwise, it means your thumb will be your thumb will be facing upwards, and therefore the current will be into the board or into your book or your screen. So meaning that the current is moving from Y to to X because it is rotating anti-clockwise. So our answer here is from Y to Y to X. That is the direction of our current. Okay, and then a maximum voltage here. Let's check something. A maximum voltage of 90 volts is generated when the coil is rotating at a frequency of Of 20 hertz. So we are given the voltage, we are given the frequency. Write down the time taken. Write down the time taken for the coil to complete one rotation. So in fact, we are looking for the period here, and we are given frequency. So T equal to 1 over 1 over F. Now what is our frequency? 1 over 1 over 20. Go to our calculator now. What is 1 over 20? 1 over 20. So we can just punch that. It's 1 over 20. What do we get from 1 over 20? We get 0.05. So that's my answer there. 0.05. Don't forget that is what? It is seconds. 0.05 seconds. That's how you get your 1 mark there. Let's move to the next question, which is 9.1.4. The statement says that the coil starts rotating from the initial position as shown in the diagram above. We have seen our diagram. we are asked now to do what? To sketch a graph of an output voltage versus time for one complete rotation. Only one complete rotation of the what? Of the coil. What are we supposed to indicate in our graph? We're supposed to indicate the maximum voltage and the relevant time values on the what? On the graph. All right. So let's go to our diagram here and see if we can get something from the diagram. Now we need to use the right hand rule as well. In fact, not the right hand rule. We can use that information that we know from grade 11 that electric field lines, in fact magnetic field lines, they always move from north to what? To south. So we can have the electric field lines here moving from north to south. So if I have these lines here, I can see that these lines are perpendicular to the what? To the coil. So if the lines are perpendicular to the coil, I know that I have cos 90 because it's perpendicular, and this will give me 0. So meaning that when I go to my graph, I must start at 0. If it is perfectly parallel, one can start at maximum. But in our case, it is perpendicular. So we need to start at 0. So our graph here will be of this nature. We need to come here, redraw. Okay, we start from 0 to here, and then we move again to this side. Okay, it is now equal. So meaning that this is 0, it must be here, the line, this is 0, and therefore this is a complete rotation. And the time we got there, was it 0,05? It was 0,05. In fact, 0,05 here, let's fix it. We have 0,05 seconds. Don't forget that we have time this side in what? In seconds. And then here, what do we have? We can fix that as well. We have the output voltage. So we have the output what? We have voltage. Okay. And therefore it's measured in what? In volts. Now the maximum here, the maximum was given to us as what? As 90. So we have 90 there. So 90, this is how you're supposed to get your max. But now, half the rotation here, what is half of 0,05? We know that is 0,025. That is half the rotation. Let's move to the next question now. To question 9. We are going to 9.2. 9.2. We have to do some calculations here. 9.2. What are we given? 9.2 wall circuits, or a wall sockets supplies the RMS voltage and current. We are given 20 voltage AC, okay, which is supplied from a wall socket to an electric kettle having a resistance of 32 ohms. What are we supposed to calculate here? We are supposed to calculate the average energy which is given or dissipated by the kettle in what? In 2 minutes. All right. So we are given that. I see something foreign here. We don't use minutes in what? In physical sciences. We use what? We use seconds. So now, how do you then convert? We must convert 2 minutes. We're going to times by what here? By 60. And therefore, what do we get here? We get 120 seconds. That's what we have there. All right. And then, what are we looking for? We are looking for energy. We are looking for energy. So we go to our formula sheet now, because we are given the resistor, we are given the voltage. So we can say that energy, which is average, so we can say energy, which is average, okay, will be equal to V squared RMS, okay, and therefore change in time over or divide by, we have R here. Okay, let's see how we can then, are we not given the voltage? We are given the voltage as 220, which is 220. Don't forget to square it. And therefore, the time that we are given now is 120 over the resistance was given as 32. It was given as 32. So we need to calculate now. So this is the energy, which is average. What do we have again here? We have energy, which is what? Which is average. Okay, and therefore we just go to our calculator now. We punch what we have here and then get the answer. We punch what we have here and then we get our answer. Let's see what we have here. We have 220, don't forget to square it. So it's 220, 220, we can square it. We are multiplying 220 by what? By 120. We divide, get the answer, you can divide by 32. What answer do we get there? We get 181,500. So we have 1, 1, 8, 1, and then we have what? We have 500. Don't forget it's joules. Don't forget it's joules. So this one here is just calculations. You punch in your calculator. Don't forget to change the time into what? Into seconds, because we're given in minutes there. Now grade 12, this is how you answer question 9, which is electrodynamics.